Let's take a look at problem 3. Problem 3 is different from the others because we're not actually looking for a confidence interval. What we're looking for instead is a minimum sample size necessary. Now, what that means is it should be somewhat intuitive that the more people you survey or the more samples you take, the larger the number of times you run a trial of an experiment, etc., you'll get closer and closer to what the actual population parameter is. For this type of problem, what we're asking is, what would be the minimum sample size to meet specific criteria? It's actually not that difficult to do. It's not as detailed as finding a confidence interval, but it's a very similar process. Basically, what we end up doing is reverse engineering the formula to find E, and we work that backwards and we solve it for N. Let's take a look at this problem first. About 3 months prior to an election, a candidate's constituents were polled, and 42.1% stated they would be in favor of a Medicare for All type of medical plan in the United States. A new survey will need to be taken about a week before the election to see if this number has changed. At the 92% level of confidence, determine the minimum sample size needed to be within 2.5% of the population proportion of those that wish to have a Medicare for All type of plan. This is a problem of proportion. So the correct sampling distribution, just like all the others, is the Z distribution, or the standard normal distribution. And since we're looking for N, but I only gave you the formula for E, we reverse engineer it. So if E equals E sub alpha over 2 times the square root of P hat Q hat over N, and I'm not going to take you through all the algebra, but basically that means N equals P hat times Q hat times Z sub alpha over 2 over E squared. Now that we know the sampling distribution and we know the formula, the next question that you should ask yourself is, was a previous poll done with the same question? If the answer is yes, we use the previous poll's result for P hat. If this is a new survey, or if we wish to start a new one on the same issue, we use P hat equals 0.5. In other words, the default P hat when we're looking for a minimum sample size is 0.5, meaning 50%. But for this problem, it states explicitly that we had a previous poll, and that previous poll showed a result of 42.1% being in favor of Medicare for All. So we use that for P hat, except we write it as a decimal, so P hat equals 0.421. The parameters, we have N equals, that's what we're looking for. P hat equals 0.421. Q hat is always 1 minus P hat, and that ends up being 0.579. E. The key word you should be looking for when we want to find E. In these types of problems, E needs to be given to you because that's just one of the criteria upon which we calculate the minimum sample size. So let's go back to the problem and see where I got that 0.025 from, and also what the key word is. Here's the original problem. It says needed to be within 2.5% of the proportion of those, etc., etc. The key word here is within. There are other keywords, but usually the word we use is within, Any other word would be a synonym. So that's the key word to get E. My level of confidence, that's given in the problem. But remember, if it's not, and if a level of significance is not given either, then we make the assumption that the level of confidence is 0.95 or 95%, and that my level of significance is 0.05. But the level of confidence explicitly stated as 92%, which means that alpha is equal to 0.08. Alpha over 2 is 0.04. When we look up z sub alpha over 2, and again, we're going to put this on a spreadsheet, we get 1.7507. And we get that from the norm.s.inverse function on the spreadsheet. When I do the whole calculation by the formula, here I have n equals, this is p hat, this is q hat, this is z sub alpha over 2, this down here is e, and I square that result and multiply it by these things, and I get 1195.355805. However, n always represents a number of things. We cannot break that up into portions of things. In this case, we're talking about human beings, and obviously we can't have a portion of a human being. So, no matter what the number is to the right of the decimal place, we will always round the number up. In other words, if this were 1195.0067, we would still round it up because this is a necessary condition for us to meet. And 1195, if we round it down, that wouldn't be enough. 1196 is a slight overkill, but since we can't break it up into a portion, then we would round up. Let's see what this looks like on a spreadsheet. Here we are in spreadsheet mode, and I have it set up already. E for this problem is equal to 0.025. P hat is equal to 0.421. Q hat, we'll let the spreadsheet do that. That will be equals 1 minus whatever we got for P hat. My level of confidence, 0.92. My alpha value is 1 minus my level of confidence as a decimal. So that's going to equal 1 minus my level of confidence. Alpha over 2, obvious. Just divide alpha by 2. And I'm going to nest two functions together. I just want to get the positive result, as I said. So I'm going to take the absolute value of the norm.s.inv. So if you have to pause this, then do so that you get the function correct. Equals the absolute value of norm.s.inv. I open another parenthesis. Excel is pretty good. If you see it has colors, when I close my first parenthesis, it's going to be for the norm.s.inv function, and you'll see that one will be red. And then when I close the second one, it will be a black one just like that. So norm.s.inv of my alpha over 2 value. I close my parenthesis and watch, it'll be red to show I'm closing the norm.s.inv function. And now I'm going to close the absolute value function, and you'll see it's black, just like the one that opened the absolute value function. So make sure you type that in carefully and make sure it looks something like that. And that way we just don't have to do the thing twice, getting the norm.s.inv and then getting the positive result. And we get 1.75068, etc. I rounded this on the problem page to 1.7507. Now we have to put this into the formula. It's not so complicated. Just pay attention to how I'm doing this. It will be equal to p hat times q hat times, and now I'm going to open a parenthesis, and we take our z sub alpha over 2, and we divide that by e. I'm going to close my parenthesis, and we haven't discussed exponentation. To create an exponent to the power of, we call it a caret. It's shift 6. And you see how that turns out. It's raised to the power of, and in this case, 2, and press enter. And you'll see we have the same number that we had on the problem page. Over here, we have a really cool function. Excel spreadsheets have round, but they also have one called round down, and they have one called round up. And then you tell it how many decimal places you want it to go. And when they ask that question in the function, they mean how many decimal places to the right. So I'll show you that function. It equals round, and you'll see we have round down, round up, and I have no idea what M round is, but there's something there for that. So I'm going to click on round up. And no, it's not the insecticide. Some people will get that. The first thing, it's asking for a number, and the number comes from right over here. It says n is greater than or equal to, comma, and it says the number of digits. It means the number of digits to the right. So basically we just put 0. In other words, we don't want anything to the right of the decimal. Now I'm going to close my parenthesis and press enter, and you'll see it gives me the 1196 number. And, well, that's about it. I mean, that is the minimum sample size necessary to be 92% confident and to be within 2.5% of the population proportion of those people who would want Medicare for all. Let's go on to problem 4. Problem 4. A survey will be conducted in Canada to determine the overall satisfaction with Canadian healthcare. Determine the minimum sample size necessary to be within 3% of the population proportion of those that are satisfied with their healthcare in Canada. Again, this is a proportion problem, so the correct sampling distribution is the standard normal or the Z distribution. There's no level of confidence that's specifically asked in this problem, so we default to the 95% level of confidence. Also, there's no previous study mentioned. There might be a previous study, but there's not one mentioned for this, so we consider this to be a brand new study. The default is we set p hat equal to 0.5. Let's take a look at our parameters. N, that's what we're looking for. P hat is 0.5. Q hat, well, that's 1 minus P hat. So Q hat is 1 minus 0.5, which is also 0.5. E, given to us in the problem, that whole statement within 3%. My level of confidence not given in the problem, we use the default of 0.95 or 95%. Alpha is equal to 0.05. Alpha over 2 is 0.025, and z sub alpha over 2 using the norm.s.in function is equal to about 1.96. We pop that in the formula. N is equal to P hat times Q hat times z sub alpha over 2 over E squared. And when I do all the math, I get 1067.1, which is approximately equal to 1068. So that would be my minimum sample size. Let's see how easy this is to do on a spreadsheet. E, well, we stated that was 0.03. P hat, that was not given to us in the problem, so that will be 0.5. And then Q hat populates with 0.5 as well. Level of confidence, not given in the problem. We default to a 95% level of confidence, or 0.95. Alpha populates as 0.05. Alpha over 2 is 0.025. That gives me a z sub alpha over 2 of 1.95996, etc. No matter where I round this, it's still going to be 1.96, and that's why I put 1.96 on the problem page. When I crunch it in this formula, and again, here is the formula if you need to see it. When I put all that in the formula, I get 1067.071895. But because there's already something to the right of that decimal, we have to round up because we cannot have a portion of a whole for n. And we would get 1068. So 1068 is the minimum sample size necessary in order to be within 3% of the population proportion of those in Canada who are satisfied with their healthcare system. This will conclude this video. I'm going to pick it up from here with other types of problems. So see you in the next video.